Hi everyone. So quick video, and I mean quick here. You open your SPSS file, and the first things are to do housekeeping. So you go into edit options. You want to make sure that it's displaying names, which is the variable name, and not the label, which is the question stem. It's done in file order. And then in your output, everything is an and names and labels, values and labels, etc. So that your output is showing both the variable name and the label. Now, as we all know, this is the data view. You will see all of your data in here. Your variable view shows you all the variables, and you can always adjust the values or the measures in this area here. Another quick way for Codebook is to go to Utilities, Variables, and you can look up any kind of variable and show you what the response categories are for that variable and the measurement that SPSS is assigning it. So, a couple things. In any categorical variable, you're definitely going to run frequencies on the variable. You can ask for quartiles and things, but you wouldn't do that for a categorical variable really. But you could get a chart here. So you can get a bar chart here. You can get it in frequencies or percentages. And then you're going to paste it in your syntax. So in your syntax, again, you 3 asterisks will make it a note, and you can say running descriptives and frequencies to understand my variables. Don't forget to end that with your asterisks. And then you can just highlight it and run. It'll give me my frequency of this variable, ab single, and it's showing me what the percentage is. It automatically has assigned missing values for 0, 8, and 9, so you don't have to take them out. In fact, you're just looking really at the valid percent because that is the total 100%, because the missing percent, the 0, 8, and 9 scores are calculated in the regular percent. So valid percent is of those who answered this variable, what's the distribution between yes and no. And so that valid percent makes more sense than looking here with the missing. So there's that. And then you could also, when you're doing quantitative variables, continuous variables like age, you're going to want quartiles, which is going to give you your Q1, Q2, and Q3. You can ask for mean, median, mode, your standard deviations here, your min, and your max. And that's basically what you want. Then the chart is a histogram with the normal curve on it, so you can see what the distribution is and if it's normal enough. I'm going to paste that. So it's in my syntax. I'm looking at age, and so when I find my output, I find all the central tendencies right here. So you have your mean, median, mode, standard deviation, min, max, your percentiles. You can calculate your range, right? Max minus min. You can calculate your IQR, which is your 75th percentile minus your 25th percentile. And then you get your frequency, which is not helpful. You would never report the frequency of a continuous variable. But then you would get a histogram. So what does this look like? Is it normal? If it is, okay, you can say it's normal enough, or if it's skewed left, positive or negative, skewed left or right, you can describe what you're really looking at in terms of a distribution. So that's for continuous variables. That's a way to describe what your variables look like. We also did crosstabs. So crosstabs are for 2 categorical variables. You go to descriptives, crosstabs, and you are looking at, let's say, that variable and that variable. You always want your row. Sorry, we haven't done chi-squares yet, but you always want your row, column, and total. And you're going to paste that into your syntax. You're going to say running crosstabs between Bible and Abhor. And after you run that in your output, I've always told you that the first one under count is a row percent. So I'm going to change this to make it row percent so it's easier and I can understand it better, and make this my column percent. And so now you have your crosstab. you should know how to interpret the row percent, column percents. These totals are the row total or the column total, which you see down here. And that's the distribution between the row variable or the column variable. Finally, the last thing that we've talked about is comparing means, and that's compare means independent samples t-test. That's for a dichotomous variable, and so sex is really 1, 2, and a continuous variable. And we're going to paste that in my syntax. So here I'm going to say comparing means between men and women for prestige. Highlight that, run that, and you're reading here. These are the means. This is the standard deviation. And you will see, sorry about that, and you will see whether it's statistically significant, which it's not. So that is the independent samples t-test. Okay, so next thing I wanted to talk about is recode. So here I'm recoding age into a dichotomous variable. And like I said, in syntax, it's the same thing. So you write recode, you talk about the old variable, which is age. And I'm saying anyone 18 through 35, I'm going to make 1, 36 through 90, I'm going to make 2 into this new variable called age R. Then you're going to have value labels for age R, 1 being young, 2 being old. And these periods are super important, right? So then I'm going to run this. Looks like it ran. How do I check that? I run a crosstab. So I can even just copy paste this crosstab down here. And I'm going to check the old age by age R to see if I did that correctly. Now it looks like so far so good. So in this column percent, all the 18 through 35, it should say 100% of the row. So like 18-year-olds should all be young, right? So this is saying 100, 100. These are all zeros. That's all correct. And then starting at age 35, I should see a shift. 36 should be 100% in the 2 column, which is true. So this is 100%. So it looks like I did it correctly. And so now I have this dichotomous variable. I can then run a t-test with the new variable. So I can copy, paste that here, and it's now called age R, and I'm looking at young and old on this continuous variable. And so when I run it, it looks like there is a statistically significant difference between occupational prestige. In fact, old, those who are considered 36 or above, are statistically significantly higher in their occupational prestige. Mean equals 44.35. Then their younger respondent counterparts, mean equals 40.87 at p is less than 0.001 in fact. So that's how you do the recodes, crosstabs, t-tests, basic descriptives, frequencies, and that should cover everything you need to know in your midterm. So yeah, thanks.